Okay, well, everyone, good afternoon. Thank you so much for joining us for our Rollup-as-a-Service panel. I'm Tracy Wang. I'm a Deputy Managing Editor at CoinDesk. Excited to moderate because we have 4 Rollups-as-a-Service projects all on stage. And so, hopefully nobody starts fighting. but why don't we just start with, if we can go down the line and have everybody introduce themselves, kind of a little bit of your background, any other previous projects you've worked on that are notable, and kind of how you got to where you are, and just like a 30-second intro.
Yeah, sure. Hello. If you weren't just here for my talk, I'm Matt. I'm the founder of Caldera. Got into crypto back in like 2012, 2013. Bounced kind of in and out of the space. Did a lot of stuff around startups, some performance engineering for things like games and operating systems, and found my way back into the space working on Rollup-as-a-Service, trying to unlock scalability for novel applications on Ethereum.
Yeah, hi everyone. Yaoqi here from Allier. So I started my research back in 2012, mainly on consensus protocol and also privacy, mainly publishing sort of research papers. But back in 2016 and 17, together with some colleagues, we started to do research on scaling, mainly sharding at that time. So we co-founded Zilliqa, and basically push the midnight for the sharding protocol. And later on, also working on some multi-chain approach. And then around 2 years ago, we started Allier to build this decentralized Rollup-as-a-Service protocol for applications to quickly spin off a rollup and scale their applications.
Hey, I'm Neil. Great to see some familiar faces here. Founded Eclipse, and prior to that, I was working at Citadel as a quant researcher in the commodities group. I did like power, gas, electricity. And then I left. I was briefly building an EVM for the Cosmos SDK. So people here might know like Ethermint or Evmos and stuff like that. So what this was instead was you take the regular WebAssembly virtual machine and you try to run EVM bytecode through that. And the advantage of doing it that way is you get better atomic composability between EVM smart contracts and WASM smart contracts. So that was the thinking. My main reason for doing that at the time was actually Terra, because Terra had a lot of momentum. So when Terra depegged, I just scrapped that project and went back to the drawing board, was chatting with the Celestia folks for a while, was chatting with some folks at Zero X Park, and finally ended up building Eclipse because we wanted to address this gap we saw in the market for really highly parallelized, high performance rollups.
Hey everyone, my name is Kautuk. Kind of started building on Ethereum in 2018, but then I caught the AI/ML hype of that time. But then I realized it was not for me. And back in 2020, I came back to the space and started learning, reading and researching more about scaling in general. I worked with the Ethereum Foundation in the PSE team, a little bit working on the Hubble Rollup project and the BLS wallet project, and also worked with LivePair for a little bit, moved the protocol from mainnet to Arbitrum. And I think last year I took inspiration from Hubble and spun up Stacker, and it was basically a framework for building rollups. And yeah, that's pretty much about me.
All right, thank you. So we are at Modular Summit, and so if you guys can briefly talk about kind of how Rollups-as-a-Service kind of fits into the modular vision of the world, and also if you can give a very, very high-level definition of what a Rollup-as-a-Service is for any of our new joiners that might not know. And I think there is this, simile that some people use that Amazon Web Services is to Web 2 as Rollups-as-a-Service is to Web 3. I don't know if that's a directly a good comparison. And so if you could kind of explain what Rollups-as-a-Service is and kind of how that fits into the modular vision of the world. Why don't we start with you, IQ?
Oh, great. So for Rollup-as-a-Service, right? So I think we are talking about modular a lot today and probably tomorrow. So as we know, right, 2 years ago, Mustafa mentioned about this Celestia and also modular. At that time, we are trying to move from this monolithic blockchain model to this modular model. So in that case, we try to decouple the monolithic sort of a design from this execution layer, settlement layer, DA layer into multiple like modules. Like Celestia handling this DA and execution basically belongs to different rollups. Like we know the Optimism, Arbitrum, and all different ZK rollups. And then we also have the settlement layer. Typical we mean like the Ethereum. So in that case, right, when we talk about modular for Rollup-as-a-Service, it's mainly like for us, like we mainly focus on this execution layer, like really run the rollups for the applications. So that's sort of the definition for the modular when we talk about the Rollup-as-a-Service. But as you mentioned, right, for, if in layman terms, it's really like AWS or cloud services in the crypto world. So people can really just define the parameters, names, and just click a button, and then quickly either use us or some of our like projects, like platform to quickly launch a rollup for the application. It's either like sort of EVM compatible, or it can also be WASM compatible, or even SVM compatible, or even like JavaScript compatible, right? It's really like in general execution layer, but mainly for a lot of these decentralized applications. Sorry, my explanation a little bit long. It's not as short like as the number one. Yeah.
I guess, Neil, do you have anything to add or take issue with YQ's answer?
I like that analogy, AWS for crypto. That's very flattering. I'm going to use that. Yeah, I feel like what's interesting, well, I won't get too much. I feel like I'll just say, but what's interesting about alt layer is that it's reducing the fixed cost substantially by making it a short-term rollup. That's kind of the idea, the ephemeral rollup. But yeah, rollups as a service, it's like managed infrastructure. This way you don't have to actually do the deployment yourself. And more than that, you don't have to maintain its reliability. Some other team and you're outsourcing that to them. Though I think where it can go wrong is when the rollup as a service is spending too much time on consulting or things like that, because that's not scalable revenue in SaaS terms. And I mean, RaaS, the whole name kind of like tries to piggyback off the connotations of SaaS.
Yeah, of course. So also, I think it is nice to make a distinction between Rollup as a service and Rollup frameworks for now. So as Neil mentioned, it's basically managed infrastructure for RaaS projects. So for us, it's mostly around like the framework model. So it's interesting that still it can be thought about as AWS, because AWS has other services also that you can use to build the cloud project as well. So for us, we think of it more in terms of like building tools for creating those state machines and like creating those rollups instead of like having a chain which you can deploy applications on. But yeah, the AWS example still works.
Well, I guess the reason why that AWS example doesn't quite work is because we don't own the hardware ourselves. At least I don't think any rollup as a service at this point owns it. And that's why AWS works so well, because they get economies of scale. When more people use AWS, their data centers grow or whatever. It's like the whole Amazon flywheel. And maybe that is the direction that rollups as a service could move in. They start to like vertically integrate even further.
Yeah, to build off of that, like I think if for a technical audience, the example I like to give are like platform as a services. So like a Heroku or like Render or Railway. There are a bunch of these that are built effectively on top of AWS or GCP, but then offer services on top. That's effectively what I think all of us are doing. I suspect none of us are running our own hardware. We're all on top of a public cloud. I think that the definition was good, so I don't have too much to add. The one thing I'll also say is like, I see rollups as a service as like the distribution layer for the rest of the modular stack, right? So if you have like the rollup frameworks themselves, right? Stacker being one of them. You have like DA, shared sequencer networks, et cetera. When people, but who are like the people and the projects that applications or people who want to build chains are going to come to? They're probably going to come to us. And so we get to act as kind of like the top of funnel for all of the amazing projects lower in the stack and help them reach adoption as well.
Yeah, but one thing to keep in mind is like Heroku never became a huge business though, because as a result, like when a company got big enough, they would just move off of Heroku. So I think that's something that distinguishes rollups as a service, which is that you want to build in something that makes it a little stickier or like builds in a network effect into the whole deployment.
If we let's back it up a little bit and kind of talk about, do you think that like kind of rollups as a service only makes sense if we exist in a world where there are like a lot of rollups? This is a two-part question. One, do you think like we need rollups, or whether you think that there will be a future with a bunch of rollups, and why do we need them as a service?
Yeah, I'm happy to go. So I think honestly, like there's less of a distinction between whether we need rollups versus like whether we need block space. Like, you know, really like rollups are on some level an implementation detail. And the reason why we've seen a lot of, you know, proliferation of rollups as a service versus like sidechains as a service, right, which could have been done back in like 2017, 2018, and kind of was done with like enterprise blockchain, but didn't really go anywhere, is that with like rollups, it's much easier to provide them as a service. The model makes more sense, and it's easier to be more aligned with a chain like Ethereum. And so that's kind of one of the reasons why we've seen proliferation of rollups as a service. And the motivation behind that is just more block space and varying types of block space on blockchain networks. So like we've, you know, all of us has probably spent some time talking about like fully on-chain games, on-chain social, high throughput applications, high latency applications, all sorts of blockchain applications that are, you know, continuing to further like blockchain as this platform for like general compute. If you see those trends moving, like you need some way to scale, and rollups as a service, I think, are just the easiest way to get there. And then the question is like, why rollups as a service versus just like rollups in general or hosting it yourself? I think it is similar to like the cloud services model, where like you could run things on bare metal. There was a time when people did that. I remember an anecdote from like the early Facebook years. Like every time they added a new university, they like physically went into like a server farm and like racked a new server and like added that to their platform. So like you could do that with in a rollups, you know, rollup world without needing rollups as a service. It's just adding another layer of abstraction on top.
Also, to add on top of that, you mentioned like, do we need so many rollups and stuff? So I personally see rollups as more on the application side of things than chain side of things. So I think the whole theme for today has been, at least in this room, has been like rollups should be as easy to deploy as smart contracts, right? So over to like right now we are building smart contracts, applications as smart contracts, but in the future, if we have like better tooling and better infrastructure on that, we can just start building applications as rollups. So instead of the applications being deployed on a rollup, application becomes a rollup in itself. So I think one of the most prominent examples is DYDX. So DYDX is like just doing before that, before it moved to its own chain. It was basically a StackX app, and that's something which I see happening more once we build better infrastructure to deploy apps like that.
Yeah, all right, so that point on like the block space being the reasoning, I guess what's interesting to me is like there's a lot of commodity block space L1s out there, and like they're far from saturated. So I actually think that the biggest reason why people deploy their own chain is economics. And that also explains why we never saw side chains as a service, because the fixed cost for a side chain, for it to actually be secure, is much, much higher. For a proof of stake chain, you actually need some amount of stake, probably millions of dollars, to secure that chain. And on top of it, you need like 100 validators, each of which is burning some amount of money every month. So you're burning millions and millions of dollars. Whereas for a rollup, the fixed cost is very low, because you only need a small number of sequencers. So what you're inherently doing is you're reducing the fixed cost, and the trade-off is that you've increased the marginal cost, because now you have to post every transaction to an L1. You have to pay for DA. But the upside is that when there is execution congestion and things like that, then you actually share in that upside. So you're going from being a rent seeker to being like more of a homeowner. So that's my thinking. And yeah, as far as why rollups as a service, I'd agree. Like it's just too cumbersome. It's not something that I think application developers should be thinking about if they're, as far as like running their own stack. Reminds me of like when people used to have their own in-house data centers. At Citadel, we used to have that actually, and it was actually much cheaper than using AWS if you don't account for the engineering time that went into maintaining that whole system. So eventually we pushed everyone to AWS. That confused a lot of the portfolio managers, because they're like, what? Like the in-house thing is so much cheaper. That's because Citadel wasn't really doing the accounting properly. They should have been properly attributing the engineers that worked for the reliability team and trying to like average out that cost as well.
Actually, I can provide some extra real-world examples because we all talk about this block space in theory, right? So we know that Rollup can provide much cheaper block space, and also at the same time, if we can provide fraud proof or validity proof, we can still derive the security guarantee from the L1s like Ethereum. But beyond that, we need some real-world example, right? One of the example I can give is that we are working with one of the biggest gaming partners right now. So the thing like they got a lot of IPs from Sega, Ubisoft, and some of them. So the thing like they couldn't really do this manual consulting one by one for their partners. So what they have right now, like collaborate with us and later use us to launch a rollout for the games, that they can make it scalable. Like for example, instead of assign like a 10 people or 20 people team, like consulting company, and to talk to different like sort of IPs, right now they can just use us to quickly just click a bunch of buttons and quickly launch that multi-sequencer with fraud-proof like rollup for them, to serve their customers. So in that case, like they can quickly like just scale the business, not just like talk to them one by one, but really like once they got the deal, and then they can quickly spin off the rollout for them. That's something I believe like probably if like all of us, like especially in the room, right, we believe in the Web3 future, we must probably eat the pie of internet industry, right? So in that case, definitely we have to envision like in the future more and more the mobile applications will use blockchain in the future, right, as a backend. So in that case, we definitely need a much more scalable and high performant like infrastructure. So what we can provide at this panel for the developers to use, yeah.
Got it. Thank you. Could we go down the line and kind of talk about, I mean, now we're all convinced that Rollup-as-a-Service is the future. Like, why is your project the one that developers should work with?
Yeah, great question. I think this is going to lead to some interesting answers. For us, we're really focused on providing the most mature stacks that exist. So OP Stack, Optimism, and Arbitrum Orbit. And also we have really, really high focus on customizability. Anything from like changing the chain parameters easily, using Alt-DA, choosing which stack to use, all the way down to like custom stateful precompiles. We've been working on interfaces to allow developers to do that more, all the way to, potentially like additional VM level modifications. As well, we have a big focus on middleware. I think one of the things we've realized is just like what it takes to produce a viable chain doesn't stop at the sequencer. We're really focused on providing additional infrastructure, looping in folks we work with other infrastructure partners, creating a broader ecosystem of modular services and modular infrastructure. And our focus is just on DevX, ease of use, and getting people to the market with a viable rollup in the shortest amount of time.
So on our side, we are a little bit more crypto native. Like because most of the team members joined the crypto space since 2016, building these public blockchains. So for us, right, we are mainly focused on this decentralization and security. So the stuff you can use all layer via our dashboard. You just click button within 2 minutes, you can launch a rollup. But what you can have is really a decentralized sequencer. You can choose the number of sequencers you have. And also multi-VM support. Right now it's EVM and WASM compatible. And beyond that, we also have our own proof system. So it's you can choose the settlement layer like Ethereum or the EVM chains. And later, like if there's anything wrong, you can have a challenger verifier to do the challenge for the proof. So that these sort of like the most of the advantage we have is really to highlight the decentralization and the security. So that's why we spent like almost 2 years on the implementation for this multi-VM and the proof system. Yeah.
Yeah, I guess my view is that like all the rollup frameworks to some degree are in their infancy, and that especially optimistic rollups, none of the fault proofs are permissionless or enabled. So to me, what distinguishes like different rollup frameworks or rollups as a service is what they chose to focus on, and consequently what they could not focus on. And because that implies a trade-off in terms of their positioning. So for us, we focused on one was high throughput and high performance. And the trade-off there is that the nodes are heavier. So they're beefier nodes, but they're very powerful. So you could run like just an unheard of number of transactions. And we have games that are posting literally hundreds of transactions per second on chain. And it would only be possible with a parallelized EVM. So that's one reason. And then the other thing is avoiding vendor lock-in. And that's something that also implies a trade-off to some degree, because it means that there's no strict allegiance to any ecosystem. You can actually pick which ecosystem you want your rollup to be aligned with. But as a result, Eclipse itself is not really aligned with a specific ecosystem. It's more like people, when they deploy an Eclipse chain, they choose the positioning for it, and they have to make that positioning known. So that's kind of how I think about it. Trying to think if there's anything else that really distinguishes, because I feel like all the integrations, things like that, like everyone has to provide a block explorer, you have to provide bridges. These are just necessary conditions to having a viable rollup.
So for us, I think we stand at a little different from all the other projects right now over here. So our focus is mostly on developer experience. So we want to build a system so that you have like a very Web 2 style of building Web 3 native applications, and that's what we are going towards. So it's not a chain that we are providing. It's a toolkit that we are providing. It has a bunch of library functions. So you can think of it as like how you develop React front ends or something like that. You have like a whole component system. You pick and place components and you just place them so that it just like builds like your own state machine. So that's the thing that we are focused on, like building, making people give them access to build their own custom state machines. And those custom state machines, we are calling it as micro rollups, because they are like literally what you want them to do. So if you want to do like you want to build a token transfers application, you just pick and place the components required to do that. If you're building a gaming application, you just take in like a ECS system and you just build a state machine out of that. So that's the mode that we are trying to build in and provide. Yeah.
So moving over to economics, like how do you envision, Rollup-as-a-Service kind of monetizing? I guess we'll start with Neil.
Well, I don't think that there's like anything realistic beyond like fixed plus variable. The question is just like, what is the variable fee charged on? Is it on like the size of the transaction, or is it based on volume or something like that? And then the question is, how much is that fixed amount? And it should be some function of the cost of running nodes. It should be some function of just like the market. It depends on like where the surplus accrues, whether it's to producers, consumers, but some variation of fixed plus variable.
So I really like the data Neil and also Matt just presented in the talk. As we know, right, I also give a talk at ECC on the first day. So the thing, like, we have to have the breakdown of all the rollups, either for the general purpose rollup or the application specific rollup. So in general, it's like they all discussed, right? So 3 parts. One is the execution cost, so you can charge these part of fees from the users, right? To cover your L2 operator costs, and probably also sometime when you post the data either to DA or to the L1. So these kind of average cost. Beyond that, they are also like regularly post like data to DA, right? So you, for games, like probably they always prefer like cheaper price. So then it's Celestia, EigenDA, and AVO probably are the better solution. But in the end, like I believe probably for all of us, we are trying to make it as modular as possible. For developers and the project, they can choose what kind of solutions or pricing plan they want. But for either it's like sort of the normal pricing plan, different tiers, or we make it like pay as you go. But in the end, it's sort of like after the cost from the running the infrastructure plus the service fees, we can charge from these developers or projects. Beyond that, I think one good thing like for all of us that if some of these rollups are quite successful, by running these sequencers or executions, right, we can sort of have some premium on the L2 fees, either from the users or from the projects. Yeah.
Right. So how many different pricing plans do you guys have then?
No, I just give one example. It's sort of like the multiple ways, right? Like you can try pricing plan or this pay as you go. It's different like models. But in general, we need to cover the cost for the L2. I mean, infrastructure.
Right, yeah, there's a lower bound on the cost.
Yeah.
Wait, so if you're talking about like hypothetical pricing plans, I'm curious like what your project currently is charging.
For me, to be honest, it really depends on the like sort of customer. So I can give you one example, like because we are providing like different types of products, right? One is so-called flash layer. So for some NFT mint and also some games, they spin off the flash layer for a few hours, and then they tear down, we roll up all the NFT back to the L1, like Ethereum, Polygon. So in that case, it's like a one-time charge just for this flash layer. And the another one is like a relatively like a persistent one. So in that case, it sort of like depends on the number of sequencers you choose and also the DA. So on our side, we can charge like sort of the infrastructure cost for the number of nodes you run. But at the same time, if it's really successful, there's a premium like sort of from the fees we can get, yeah, something like that. But still, right, it really case by case. Some game providers, I mean, we work with them. They charge nothing from the users. Yeah, they really charge nothing. So it's a zero gas we provide. And basically, in that case, we can only charge the fees from the game providers. Yeah, it's really case by case at the moment. Yeah.
Yeah, so gasless transactions are interesting because how do you prevent spam with that specific architecture?
So for these games, right? They have the whitelist. Yeah, have a whitelist for
So
users.
there's some kind of built-in
something
stable
like that.
resistance, basically.
So that's why I say it's really case by case. I mean, a lot of these Web 2 applications, probably Stacker has similar experience. So their requirements are quite different from the crypto native like applications. They don't really know how to install MetaMask. They don't really care, like you tell them like 15 seconds, 2 seconds, they don't care. They just want 100 milliseconds. Yeah, so what can you do? We have to make it very fast, but at the same time, need to fulfill their demands on all this stuff. That's why it's just some examples, but in the long run, definitely we can choose our customers, right? If we're becoming very big.
Yeah, well, I guess like once you have a self-service thing though, then you can't do it so like case by case. You have to have some like standard pricing.
Yeah, if I might jump in here, I think like one of the interesting things about the RaaS space in general is like any given pricing structure has like certain kind of failure modes, right? Like if you're charging like, you know, a flat fee for hosting, maybe a small amount per transaction, you might end up securing like billions of TVL, making like a few grand a month. On the other end, like, you know, if you're trying to charge based on TVL or bridge volume, you might be supporting like an on-chain game with no activity for very little. So I think like pricing models, yeah, like it does sort of need to be a little bit bespoke when you're thinking about different types of applications. And like really, like at least for us, like our North Star is just like we want to price it so that the user feels like they're getting a fair deal, like with the value we're providing, and that might be different for different types of applications.
Yeah, that's an astute point about the failure modes of pricing models, and actually offering different pricing models makes that problem worse because then like the amount you make is the minimum of all of those. You end up with like it's like not a great outcome actually. You have to kind of accept the failure mode of your pricing model.
Well, it's like something of like an iterated game, right? Like yes, they're like you could find like someone could act adversarially here, but like you could just like presumably you're actually providing value to them. They have some value, you know, that they're willing to pay for.
Well, I think like you can at least assume that people are economically rational, right? They're going to pick the best deal for their application. So if you have like two pricing structures, people always pick the one for their specific application that's more favorable for that app.
Sure, but like, you know, if like the company ultimately has the decision, like the power to make a decision there, right?
Yeah. Yeah.
Like I mean,
so
like
you're saying
like
you
us
would pick the one that's
Rollups
more
as a
expensive for them?
no, I'm saying that the Rollups-as-a-Service company has the decision of how to deal with.
Oh, right. Yeah. You don't have to offer multiple options.
Yeah.
Yeah.
I mean, it's just like typical enterprise sales, right?
Also, like, it's a question from you guys, like how we see things differently on the experiment side. But how do you feel like the companies running the application, like putting it the charges onto the user? Like, how do you see that happen? It's just like, what are your thoughts on that?
Oh, that's a good question. I think in certain cases it makes sense. Like you mean basically charging users transaction fees. Like it makes sense in general. We as a company, we're very skeptical on business models that are entirely dependent on that, on user paid transaction fees, just because there's like pretty massive incentive misalignment there, right? Like, you know, there are some folks like working in the space who are like, you know, they're taking some percentage of fees that users are making. And like, it makes sense now. And you'll see a lot of like VC tweets talk about this with like Optimism or Arbitrum, right? I don't know if anyone in the audience has seen these tweets. Like, you know, once 4844 gets merged in, like the margins that Optimism and Arbitrum are gonna make are like gonna go to the moon. Like what's actually gonna happen? Fees are gonna come down, margins aren't gonna go up, right? Margins are probably gonna stay roughly the same.
Well, it depends on like how that surplus is distributed, right? When costs go down for a business, they can also make more money. Or it can be completely passed on to the customer.
That's true. But like historically, what we've seen is that these get competed down to like to very little.
I think that's because Optimism and Arbitrum though offer commodity block space. Like the user or the dApp developer doesn't care about whether they're deploying to one of those or the other, and therefore like they compete directly, right?
Yeah, that's correct. It depends on how you view like the Rollup-as-a-Service space. Like, do you view like on some level there's differentiation? I think like we know that like when users talk to one of us, they're talking to like most of us, and so like on some level there's commoditization.
Yeah, I agree with that. Yeah, the biggest benefits, which is economics, are common to all chains.
All right. Let's move on to developer pain points. What are some of the, common pain points that, teams that you work with bring up, and kind of how do you plan on solving them? And then also I want to leave some time for questions from our audience after this question.
It's got to be liquidity fragmentation, I think, and interoperability. And that's a tough one to answer, because for a lot of apps, the right answer is that a rollup at this point is not quite right for it. If it really needs to do heavy composition, especially atomic composition, and even through shared sequencers. Espresso had this awesome workshop yesterday on shared sequencers, and they gave this toy example about a bank, and the bank contract is on 2 chains. It shares a sequencer. So that sequencer produces full blocks for each of the 2 chains. And what you want to do is you want to put USDC on one side and get DAI out of the other. And the tricky part is making sure that it doesn't fail, and it doesn't you don't put USDC on one side and the DAI doesn't come out on the other side, or vice versa. DAI comes out and USDC does not go in. And that basically relies on the builder providing a block which is correct, because the builder can execute all the transactions. They know if the block they submitted is going to revert or not. So you want to make sure that that builder is acting honestly. So then they said, oh, well, you can just have the builder put up some stake. You can slash the builder. And that, to me, that was a fun example. But after the talk, at first I was like, that seems reasonable. But then for an hour after the talk, I was like, there's so many failure cases for that actually. Because if the bank could lose out, and there's just collusion issues, the stake size, it was the devil's in the details there. And also, how do you prove the transaction failure? Do you use the L1 for? But maybe this is a tangent. But my point is that atomic composability is really hard to achieve between rollups. So as a result, you basically have to kind of focus on apps that don't rely on that so much across chains.
Okay, I will continue using the real cases we handle recently. I think the major issues right now is still about technical issues. We have some back to the sort of the partner, right? They ask us to have this kind of latency. You can have a try. It's you must provide this less than 100 millisecond, and basically you play a fully on-chain game, every move on-chain, but at the same time it's seamless and no latency. That kind of the ridiculous requirement asked by our partner. So the deal is can you achieve it? If you cannot achieve it, then forget about it. So we have to spend a lot of time, a few months, to really optimize and re-implement the execution layer ourselves to make it EVM compatible, but to achieve this less than 100 millisecond latency. But this is something an extreme case, right? One case like this. Another case we also got some crypto native partners. They want super decentralized sort of roll-up system. They don't care about latency, but they want it as decentralized as possible and as secure as possible. Better you have a lot of sequencers, but at the same time you must have a proof system. Otherwise we won't use it, because this one is used for public good or something that. So it's really from one extreme to another extreme. This includes a lot of this technical development to tackle a lot of technical challenges which the existing general purpose L2 haven't solved yet. But as sort of a provider, we have to solve this technical question probably ahead of the big players in L2 space. It's just that's why I highlight a lot of technical challenges here. But do you think it's worth it? I believe so, because we all dream probably for the next 10 years it's a world for Web3, right? So we want to handle billions of users to use blockchain for in the normal application. So in that case, latency, we need to solve it. Decentralization, security, we also need to solve it. These are all the great properties for blockchain. But at the same time, you can see, right, I feel we are still in the early stage. It's not we are talking about RAS and we feel we already have 4 great companies, but at the same time, there are a lot of new problems we need to solve. And I believe it's still early, and we really need together fix all these solutions for that. Yeah.
So also we see developer experience, like building in Web3 itself as a developer experience problem, and that is also something we would want to optimize for. So like if you're building a game, you write some component in Solidity, then you write a front end in some other language, and then you connect them, and like they just like it's just hard. The integration is just hard, and also like you mentioned, like the latency issue. So we kind of categorize it as two different things: the developer experience and the user experience, and we kind of like optimizing for both. So you get like both like the Web 2 experience for building Web 3. Like I've been saying that over and over. So that's the kind of thing that we are solving for on the experience side of thing. It's not just the developer experience, but also the user experience that needs to go along with while building applications.
Yeah, I want to leave some time for questions, so I won't rehash what they said.
All right. Do we have any questions from the audience? No.
In the case where you have applications that are seen as killer applications, do you expect that you have to compete between the four of you and offer sort of concessions to them to get them to build on you instead of some of the other people that are there?
I think there are cases when a roll-up framework is uniquely suited to serve a particular application. And to me, things like virtual machine compatibility actually they actually represent a reduction in fixed cost or one-time cost for a user to use your RAS. For example, like if you have SVM compatibility, technically a chain or a dApp coming from Solana doesn't have to use you, right? They could use an EVM chain, rebuild all their smart contracts in EVM. And that's what's funny. When I remember when Starkware was writing the contracts for DYDX and Cairo, people were dunking on that a lot. But actually, they were to me, Starkware was doing exactly the right thing. All they were doing was, it could have been built by DYDX, or it could be built by Starkware, but that's just some cost that's being incurred by someone. They're just saying, we're not going to pass it on to you. We're gonna incur it ourselves. So I thought that made sense. But yeah, there are cases where yeah, definitely we'll be talking with a few different, like they'll even just tell us, hey, we're talking to these other folks. These are the models that they've given us. Like, could you just like highlight the differences rather than giving the whole rehash?
Yeah, I think I mean, you mentioned concessions. I think people are less focused on concessions when it comes to like pricing and business model than they are on like which service makes the most sense for them. Like this is for a lot of applications like the biggest infrastructural architectural decision they will like ever make, at least for like that version of the product. And so like typically we find it's more on the fundamentals than on like price or anything else.
Should I just shout? Thanks. On some level, obviously, you're all kind of competing with each other, but I wanted to ask who you view as your biggest competitors, maybe in kind of an unexpected way. You know, is it no, hang on. Pick someone to cage fight amongst the four of you. No, is it like app developers looking at like the Cosmos ecosystem to have more modularity and control over their stacks? Is it other L1s? Like, what are the alternatives that your customers are looking at outside of launching their own rollups?
It depends on the stage of development that the application is in. It depends on the vertical and things like that. But overwhelmingly, the competitor is actually the status quo, just whatever they're already doing. Because it just is cost for them, but they have to put in a lot of effort to switch to another chain. They're not necessarily even going to have their own chain. I find that usually it's not between like Cosmos L1 versus Rollup. I find that that's not as common as I would have expected. And I actually thought that we'd be competing with Solana more initially. Just because they're also a high throughput chain. And then I guess Solana just kind of fell out of favor, became totally irrelevant. Oh, they are. No, I think it's Solana. I'm super like long, like Tolly and those guys. I think they're really smart. Yeah, but that's just reality, like who we typically find we're talking to.
Yeah, I think to his point, like the stage of which the project is at, it's the most important thing. So some may want to spin off of an existing L1 protocol to a Rollup-as-a-Service, or some projects which are just starting out might just pick a chain to just build off of, or a framework to build off of. So I think that's very important.
All right, I think we're out of time now, but let's give a big round of applause to our panelists.
And a round of applause to our moderator, please.